we're going to look at some discussion questions here. So the first one asks, can work be positive and negative? Can it be positive and negative? It's a scalar. And so what happens is when we multiply two vectors together here, if one of them's positive and the other one's positive, I get a positive value for work. If one of them's negative and the other one's negative, I get a positive value. But if one is positive and the other one is negative, I end up with a negative work. And so yes, it is possible for us to get positive and negative work. Positive just means that the force and the displacement are in the same direction. Negative means that they're in opposite directions. And then lastly, if they're perpendicular, well then no work is done. And we'll remember that work is a transfer of energy. And so if you're not pushing on the box in the direction it's moving, you're not transferring any energy to it. That's what that's telling us. So we're talking about a scalar again, but we have these positives and negatives. And so positives and negatives are not spatial directions, okay? So we have to think about what is work, okay? Work is that transfer of energy, and we can find it either using this equation or by finding that area under the curve. And so how we get a negative area, you'll remember, is just if that area is underneath the axis or above the axis, it would be positive. All right, but when we find that work value, it's telling us about a transfer of energy. So that's what we got to focus on when we think about this positive and negative. Energy being transferred either from input to kinetic or from kinetic to gravitational potential energy. Whenever energy is transferred, it's work. That's what work is. It is a transfer of energy between these types of energies. That is what work is. So what is the positive and negative telling us about that transfer of energy? It's telling us about the direction that energy is flowing in our picture. And so kinetic energy is at the center, so everything references that as far as work goes. So if energy is going into kinetic energy, it's positive work. If energy is going out of kinetic energy, it's negative work. And so here, these works are kind of nice because they can do both positive and negative works, whereas our input energies and our lost energies, those are only one direction. All right, so work tells us about if energy is flowing in or energy is flowing out based on if it's positive or negative. Two more discussion questions here quick. Can the total work done on an object during a displacement be negative? Okay, yes. So the total net work, so what they're telling me here is if I add up all the inputs and outflows of energy from kinetic energy, can I have a net negative? Yes. That means I'm overall removing energy from the kinetic energy. So what must that object be doing? Slowing down. We've removed some of that kinetic energy. The second part of this question says, well, if the total work is negative, can it be larger than the total amount of energy I started with? Meaning, if I have something with 10 joules of kinetic energy, can I remove 12 from it? And the answer is no. Think back to chemistry class when we talked about absolute zero. The coldest something can go. And you'll remember temperature was the average kinetic energy of the particles. And so the idea is that once you've removed all that kinetic energy, you can't remove any more. You've reached the bottom. And so once something comes to a stop, you can't stop it any more than stopped. So no. Number 4 says an elevator is hoisted by its cables at a constant speed. Is the total work done on the elevator positive, negative, or zero? Okay, so as my elevator is going up at a constant speed, that's the key idea there. So what is my kinetic energy doing? Staying the same number. Even though I'm adding energy in to lift it, that energy is then going back out as gravitational potential energy. So that overall kinetic energy change, zero. All of the energy you put in is going to increasing the gravitational potential energy of that elevator going up. All right, so those are those discussion questions for us. So let's go ahead and take a look at some more calculation type stuff.